My screen is visible, right?
Yes, sir.
So we get f of x is given as minus x square plus 4x plus k minus k minus of x square minus kx plus 4.
Sir, subtract the other way around. It will be easy. Minus will be cancelled up.
Subtract the other g of x minus f of x, is it? Oh, okay,
Right.
fine. I can directly write it. 2x square plus 4 minus k of x. Correct me if I'm going wrong, okay? Plus k minus 4. Right? So just
Yeah,
this
right.
will be minus 2x square. No, this is
K minus.
2x square. This is 4 plus k x plus 4 minus k. So this will be 2x square
Minus of K
minus
plus 4. Yes, sir.
this one. So discriminant will be, yeah, if it is at most, discriminant should be less than or equal to 0.
Yes, sir.
Now discriminant is 4 plus k whole square minus 4 into 2 into k minus 4. Should be less than or equal to 0. 16 plus 8k plus k square minus 8k plus 32 should be less than or equal to 0. K square plus 40. This one. Am I correct?
Yeah, sir, it's correct.
16 plus 8k plus
Sir, I
8
think we get minus of K minus 4, I think, sir.
minus
4 minus k, sir, constant.
4 minus
Yes,
k.
sir. 4 minus. Yeah.
Minus k minus 4,
And it
right?
is minus 2, no? So
This is minus k minus 4. So this
Yeah.
will be k plus 4.
That will be minus.
So this
a
will
is also
be
minus 2.
minus
Minus 32 will get, sir.
minus 32. This is minus
K
16.
square minus 16 less than or equal to 0.
Okay, k square minus, so k square should be less than or equal to 16 and k should belong to minus 4 minus 3 minus 2.
Yes, sir. But instead for the solution, they took K square equal to 16.
Okay, thanks, good, correct.
So I don't have access to the Discourse forum, sir. So I wrote to support, but I just wanted to mention this to
Right,
any
right.
faculty.
Absolutely correct. Whatever you said is absolutely correct. I will take a look into it. So it should be exactly 1 point instead of at most, as we have given at most to you. Then yeah, 9 should be the correct answer. So
Oh, understood.
you made many people's life complicated now. So those who have given answer 2 for this might lose marks. Anyway, we will provide them partial marks, but let's see. Okay, thanks for pointing this out.
Thank you, sir.
Yeah, yeah.
Sir, but it is written at most at 1 point. So that means like that curve, these two curves intersect at only 1 point, right?
This is at most, right?
Okay, okay,
At most can be like either it will not intersect
okay,
or it will, if it intersects, it will intersect at only 1 point, right?
okay,
Not
okay,
intersect is discriminant should be less than 0.
right,
Only
okay,
1 point is discriminant is equal.
okay.
Okay, yeah. May I know your good name? Someone
Rahul,
mentioned
sir.
Rahul. Yeah, yeah. Thanks. Okay. So, okay, in this today's session, we are going to look at some problems which are replicas of graded assignment of week 5. So week 5, you might have learned many things, starting from one-to-one vertical line test, horizontal line test. What is a one-to-one function? What is exponential functions? What are composition of functions and what are inverses of the functions? And a lot of content we discussed in one particular week. And I hope Vicky Kumar Sharma has detailedly explained in the previous session. So let us take few. Is my screen visible? Which screen is visible?
Sir, that the notebook one. K is equals
Yeah,
to
you
9.
wrote
Sir,
that.
notebook
Okay,
one.
okay. I will just.
Sir, this is solved with instructor session, no?
Right. So yeah, meanwhile people just join this joinpd.com.
Sir, code. Sir, this is
Code.
quadratic equation, right? That was a quadratic equation.
Which one? Yeah,
What?
that was yeah, that was a quadratic equation.
Okay. Means I got means we are having exponential, then y quadratic.
Okay. We are just discussing quiz qualifier paper.
Okay.
So now I hope my screen is visible now. The new
Yes,
one,
sir.
joinpd.com thing.
Sir, can
Right.
I say something about graded assignment?
Graded assignment of
Actually, a few days before, I see that there is a material graded assignment. There is a part 1 and part 2, but now it shows in the material that only one graded assignment. Is there any change?
you are talking about mathematics only, right?
No, so I think she
In
is talking
Mathematics.
about
statistics, sir.
statistics.
Yes,
So
sir.
statistics, I am not aware.
Statistics is having two graded assigned P and Q
Okay.
part.
Then, sorry, there may be
No
some
problem.
mistake.
This is mathematics. Okay, so yeah, those who have joined this Zoom also join in this joinpd.com. Go through this link and type this code OMPBZW. And yeah, it's 33, 34 I can see. So yeah, whoever are in Zoom, try to join this.
Joint, sir.
Yeah. Okay, let us start. So today we are going to discuss week 5, some replica questions of your graded assignment. Yeah, no need to explain, I guess. The same thing. Join this join
Sir, I
PD.
have a question. General question. Sir, is there a way to contact that if we have some problem in some questions or all, we can ask in live sessions. Except that, how can we contact you?
How can direct? So there are LinkedIn profile, right? You can message in LinkedIn or you can mail us directly. I hope you have our official mail IDs. You can get
Sir,
it
can you
from
share that
discussion forum.
mail ID, please?
You can get it from discussion forum, right? When I reply you to some thread,
Okay.
the side there will be my mail. So you can reach out in many ways.
Okay. Thank
But
you, sir.
even if you post it in the discussion forum, we anyway respond you. Maybe it may take some hours, but we will respond.
Okay. Thank you, sir.
Okay. Yeah.
Sir,
Thanks.
sir, I have a doubt in activity question 5.2.
Yeah. So once the agenda of this session got finished, I will take.
Sir, I also want to share some important information with you. We have a live session for statistics also today. It is from 7 to 9.
I
The
will.
sessions are back to back, so
before 7.
we can make it quick.
Yeah, I will take it real quick. Okay.
Thank you, sir.
Okay. Keep a notebook and pen ready, and yeah, question will be shown. 5 to 10 minutes will be given to you. If you are done solving, just enter your answer on the join PD. No need to enter anything. Just enter your answer. No need to submit anything. And later, one of you or I will provide the solutions and later questions and discussions. So these are some example screenshots. Yeah. So let me check once whether no this is working or not. So how many marks do you expect in quiz 1 or qualifier? So if you are giving qualifier, how many marks you are expecting? So everyone please respond because we have this data with us. We will later take it to Excel sheet and we will look at. So this will be one good data. Okay. Let me see the responses in a grid version. So okay, more than 40, 123. Nice. 20.1 into ENO. 20.1 is enough, huh? Okay, I got you. Don't type. Okay, 140 plus 50 to 60%. I want to get good marks. Okay. Not calculated. Not calculated. We have released the answer key, right? Just calculate your scores and you will get your scores.
Sir, out of 4 options, if 3 options are correct and we marked only 2 of them, how much marks would we get?
If you have
Out
not
of
selected
4 options,
wrong,
all the 4.
For example, if some options are correct and we marked only 5 of them, do we get marks or 0?
You will get marks. If you have marked all the correct answers only, you will get partial mark.
We will get partial marks, right?
Partial marks. Yeah, of course you'll get. Okay, I can see everyone is going to pass except a few. There I can see 10, 15. Yeah, most of you guys looks like you passed in max or quiz. Okay, let us start without wasting any time. Let us start.
Sir, can I ask something?
Yeah.
When will we know our quiz 1 marks? Like how in a dashboard?
Yeah, you will get it soon because scores have been finalized and maybe
Okay.
by
There
this
are only
weekend.
2 quizzes, right, before the end term exam?
2 quizzes, right? One is
I guess it's on 4th February they are releasing the marks.
okay. Maybe day after tomorrow you will get your marks, it seems.
Sir, if there are only 2 cases, then how they take that? Means I have seen in dashboard that they will take best 2 cases out of 3.
Out of 3?
Yeah.
There are only 2 quizzes.
This time we have. It was previously last sem, not this sem.
Previously it was 3, but this time we reduced it to 2.
This will already be counted in that set. Only one will be happen after the next
only
time.
one will be happen after that.
Okay.
You have your formulas, I guess. If you have attempted only one quiz, what is the scores you are going to get? If you have given 2, okay, those all are pretty.
So what would be the portion of quiz 2? Like how many weeks?
Quiz 2 is from weeks 5, 6, 7, 8. Also from weeks 1 to 4.
Okay, sir. Thank you, sir.
Okay. Let us come to this question and let us try to solve this. Suppose 2p is equals to q, where p and q are some real numbers. So one real number is twice of the other. So what I want is find the value of 4 to the power p by 2 to the power q plus 25 to the power q by 625 to the power p. So I hope it's a matter of calculation. Once everyone know what is exponential functions and how they behave, what are the values, how to compute the values, it is an easy case. So take some 3 to 5 minutes. Once you are done, just answer, submit your answer, just enter your answer.
Sir, where do we have to enter the answer?
Are you using phone or laptop?
Hello?
Are you using phone or laptop? Don't answer in Zoom. Just join this joinpd.com. So whatever the code you are seeing on the right top, OMP, this is the code.
BZW, right?
Yeah, this is the code OMP BZW. Join this joinpd.com and enter this code. You will get into the slides which I am scrolling now. Okay, there you can enter your answers.
Okay, sir.
Don't submit your answers in Zoom chat box. Okay. HP is your name or the laptop name?
Sir, once we write the answer in this join PD, then we have to put enter or just write it?
No, just write it. That is where we tested our.
Can you see my answer right now? I am a bit confused sometimes.
I will get your answer. So
I am speaking.
The spreadsheet,
So
I will
like
know.
after writing the answer, we don't have to do anything, right?
You don't have to do anything. Just enter your answer. That's it.
Okay. Thank you, sir.
But how do we know that whether the answer has been submitted or not?
How do you know? Once I scroll down. Just check or
Sir, can you
see
check
the
for mine? My name is Anand. So can you?
joinpd.com works like that. No need of submitting.
Okay.
So once you
Okay.
enter,
Okay. Okay.
Believe on technology.
Right.
Once you write your answer, a tick will appear in a box at the bottom of the screen.
Oh yeah, it's there. Okay. Okay. If I delete it, let me see.
A blue tick will come. A blue checkbox, white tick.
Yeah, I also thought so. Yes.
okay.
Okay. Thank you.
So done, everyone.
Yes, sir.
Done, sir.
Yes, sir.
Yes, sir. Yes, sir.
Easy one, right?
Yes, sir. It was easy.
Okay. So how many of you submitted graded assignment already?
I have done, sir.
Not
Submitted.
done.
Okay. Try submit your graded assignment of week 5 by today or tomorrow, because February 9th is the deadline for week 6 also. So focus on week 6 too.
Sir, is it possible that the deadline be extended a bit for week 6?
See, the thing is, you might be looking it in the wrong perspective, I guess. Now week 5 deadline has been pushed. So
Yeah,
which
it's the
means the
6th of February.
deadline has to be far before quiz.
Okay,
Right?
sir.
Last Wednesday should be the deadline of week 5, but we pushed it to this part. But if we
Yes,
push
sir.
this also, finally what happens is we have very small a very minimum number of graded assignments to calculate your score. So we have to prepare hall tickets for your end term, right? So for that
Yes,
we
sir,
require
that's true.
time, right? So if we
Yes,
push
sir.
deadlines of later weeks, so we are going to get only 4 or 5 6 assignments, maybe, hardly. So we
Okay, sir.
have, that is why it's not possible, but we have given enough time, right? 9th is pushed deadline. Okay, yeah, उससे ज़्यादा we cannot push.
Yes, sir.
Yes, sir.
Okay. Okay, so I got 65 responses out of 94. Let us see how many of you have given. Okay, I can see most of you have given 2. 2, 2, 2, 6, 1. Okay, 1 and 6. Are there anyone here would like to share their thoughts, how they got 1 or how they got 6? No? Okay, then let me proceed to the solution. So as we know from the properties of this exponents, this 4 power p by 2 power q, I can write 4 power p as 2 power 2p, right? 4 I can write it as 2 square. 2 square whole to the power of p is nothing but 2 power 2p. So 2 power 2p by 2 power q plus the same thing, but this side it is in the denominator. 625 I can write it as 25 to the power 625 is nothing but 25 square. So 25 square to the power p is nothing but 25 into 2 into p. So that will be 25 power 2p. So the whole expression will convert into like this. Now if it is a to the power p by a to the power q, we know that that will convert to a to the power p minus q. The same thing happened here. I can write the first term as 2 power 2p minus q and the second term as 25 to the power q minus 2p. Right? These are some properties of exponents. So a to the power x by a to the power y, I can write it as a to the power x minus y. So we know that it is given 2p is equal to q. From that we get 2p minus q is 0, or I can say q minus 2p is also 0. Both are true, right? I just substitute these values 2p minus q as 0 and q minus 2p as 0. What I will get is 2 to the power 0 plus 25 to the power 0.
Sir, please proceed.
0
Got the
is 1,
solution.
anything
It
to the
was an
power.
easy one.
Someone speaking? Okay, any
No
number
doubt, sir.
to the
No doubt.
power 0 is 1, right? So 1 plus 1 is 2. So the answer is 2. So those who have answered 1 or 6, correct yourselves. So this one looks little easy, right?
Sir, we are using exponential formula only when the question will be available with the log function, na? But here is no log function. Then why we are using that exponential function formula?
Where we used exponential?
Means here you are using now that's the a to the power p by a to the power q is a to the power p minus q. That is the exponential formula. So this is log exponential formula. Na?
This is not log exponential. This is for...
Exponential doesn't mean e all the time. Exponential is a characteristic.
Okay, so
It
you are talking about
can
natural exponential function. So exponential functions are of the form a to the power x. Some f of x is equal to a to the power of x, where a is greater than 0. Okay.
Okay.
Anything of this form is an exponential function. So we have seen quadratic functions, we have seen polynomial functions. So they will have one form, right?
Yes.
So what is the form of a quadratic equation? So how will the
square plus bx plus
ax square plus bx plus c is equal to
yeah,
0.
so f of x is equals to ax square plus bx plus c if there is a function of that form. So those functions are called as quadratic.
Quadratic function. Yes, sir. Correct.
In the same way, when there is like f of x is equals to some a to the power x, okay,
Okay.
where a is some positive real number. So if you see any functions of this form, so these are called as exponential functions. And in among those exponential functions, if your a is equal to e, the e, exponential e, so that
Yes.
particular case is called natural exponential function, natural.
Oh.
So see the difference in lectures. I guess professor has explained it clearly. Okay.
Okay.
These are exponential functions. So 4 power p. Okay.
Oh, okay, sir. Thank you.
Okay. Okay, let's move to the second question. So very big question. Half-life of an element is the time required for half of a given sample of radioactive element to change to another element. The rate of change of concentration is calculated by the formula A of t is equals to A0 into half power t by gamma, where gamma is the half-life of the material, A0 is the initial concentration of the radioactive element in the given sample, and At is the concentration of the radioactive element in the sample after time t. Okay, this is a big data we have given to you. What I want is, if radium has a half-life of 1600 years and the initial concentration of radium in a sample was 100%, then calculate the percentage of radium in that sample after 2000 years. Okay. So you know what is half-life in your formula, you know what is A0 in your formula, you know what is T in your formula. You just have to find A of T in percentages. Okay. So this is a quite calculation involved here. So take some 5 to 6 minutes to solve this. Sit, take your calculator or whatever, use calculators or whatever, and compute. Compute the approximate percentage. Okay, no need to be exact. Approximately, just type an integer. Okay. So I will be back in 2 minutes. I will just have a sip of water. Okay, those who have joined late, so let me say it again. Just join this joinpd.com and type this code OMPBZW if you are wondering where to answer or what to answer. So just join this joinpd.com and type this code OMPBZW and you can enter your answers there. So you can use laptop or mobile.
Sir, I have a doubt regarding E by the time people are solving this question. Suppose the N is very small, right? In this case, the approximation is not correct. So whether we should use the E formula or the normal formula in that case, the answer is varying a lot. Suppose 1 plus 1 by 2 ki power 2, if we take that as E, so it will, the answer, if we take that E or we take that 1 plus 1 by 2, then square it, it is varying a lot. So how the
what is taking E?
one
You are talking about base thing.
Yeah.
Okay. So what should be if what is base is very less is your question.
Right. When N is very small, then approximation of E is not correct, right? So answer is coming a very different answer. There is one such question in graded assignment.
Can you name out number it?
It is like 34,000 is the principal thing. I'm just missing the question right now. And after it's about population growth after 10 years, right? After 5 years, the rate is 10%. So if we do it by two, methods, by one by just normal way of doing it power 5, the other is taking it as E. So answer is differing a lot because the actual amount, the original population is very high. Let me tell you, sir, the question number if I can see.
Okay, you are saying that I am taking E for 1 plus 1 by N to the power N.
Yeah, when N is very small, sir, like 2 or 3 or something like that.
Then in that case, it is not E. So 1 plus 1 by N to the whole to the power N.
Yeah.
N takes large values like when N is tending to infinite. Then only that will be E. Okay. When N is very small, like 5, 10, 15, even 1,000, even 20,000, 20,000 or 2 lakhs. Okay, these are all very small quantities compared to infinite.
Right.
Okay, then it will not be E. Okay, you cannot take it as E. You have to compute it substituting those values itself. Okay.
Okay, sir. Okay.
Okay. So
Thank
I
you,
got
sir.
only 44 responses. Is this question too difficult or people trying to get the answer?
It's not difficult, but the answer is varying. Like first time I got something, and second time I got something, third time again I'm getting different.
Okay, let's see. So don't try for fourth time. Maybe you will get some other thing. Okay. Or if you are doing statistics, try it for 4 or 5 times. Take the mean out of it.
And then average.
हाँ सर वो सही रहेगा.
Okay, take some 2 more minutes then. So just tell me what is a gamma here?
1600.
1600, sir.
What is T here?
2000.
What you have to compute?
1 by 2 to the power of 5 by 4. Final.
No, just tell me in this variables.
So 80. Percentage of concentration left, right?
Yeah. A of 2000, right?
Yes, sir.
Yeah.
So that's it. Just do some. So what is this 100% telling me?
E naught.
Initial concentration.
Initial concentration of radiation.
Right. So from there, just try to substitute, right? You know A naught, you know T, you know gamma, you know everything. You have to just compute A of T. Okay, just
Sir, we have to first calculate gamma.
Gamma is given, right?
Sorry, that Y, what you call it, gamma, no?
That is gamma. Gamma.
That is
What is
gamma.
gamma here?
Gamma is 1600.
Gamma is 1600.
Half-life.
You answered, right? 1600. Yeah, you know A0, you know T, you know gamma. Just do some calculations and you'll get A of T. I already mentioned, no need to be precise or accurate. Okay. You can just take approximation to some integer, very nearest integer.
Are there any solutions wrong in activity questions?
It shouldn't be because we have crossed.
Sir, there is one question which I have to ask.
F of x is equal to just like 1 by x. Question number, activity question 5.2, question number 3.
Wait, let me note it down. Activity question 5.2.
Question number 3.
Okay.
And activity question, activity 3, sir.
5.
In that question number 1, 4, and 5.
1, 4, and 5. Nah, these many are wrong. Okay, let us see when we are done.
I have doubts in these questions.
Yeah, I will take it. So Purendra, you are telling something somewhere, something is wrong.
Yes, sir. Actually, one of the
Yes,
questions.
sir. One of the questions
There was a
says
root
that it is
question.
not a function, right? And when I plot using Desmos, it comes out to be a function because we can plot the graph of that. So I want to know why is it not a function?
Yeah, we will look at using Desmos itself. Okay. So I got 65 responses. Let me see. Many of you are struggling with calculations. I can see 42, 42.05, 42, 42, nearer to 42. But I can see something 56, 78 also. 6.25. Okay, most of you have given 42. 40 as much as I can. Okay. Nice. So most of you have given good answers. So yeah, this is how we follow. So our step 1 should be like, we know that the function, an exponential function is given to us. A of t is equals to a naught times half to the power t by gamma. And half-life is given as 1600. So that is what half-life is. And gamma represents our half-life. So gamma will be equal to 1600. And also at the same time, t is also given to us, which is 2000. So what we have to compute is,
I have a question. How to solve 1 by to the power 5 by 4? How we can simply solve this without calculator or any other equipment?
Without calculator, it is not possible. But we provide you calculator, right?
Okay, sir.
Or else, see, the thing is, what I can give you is, it will be 1 by 2 power 1.25. Right? 1 by 2 power 5 fourth root of 32. Where will be this fourth root of 32 lie? If you know fourth root there, you can compute, but use calculator. Without calculator also we can compute, but use calculator. Okay.
You can use Desmos if you do not have the calculator.
But in exam we are not going to allow you to use Desmos, right?
Oh yeah, of course. In exam you cannot.
So what we have to find is ultimately a of 2000 we have to find in terms of a naught. So a naught is the initial concentration, which is 100%. But we want the percentage, how much percentage is left after 2000 years. So if a naught is 100%, what will be a of 2000? So that is what we have to find. So once we get a of 2000 as a naught into, just substitute that 2000 and 1600, t is equals to 2000 and gamma as 1600, we get a naught times half power pi by 4. And then our second step will be like, at initial time, we said the concentration of the radium is 100%. So if you substitute T is equals to 0, A of 0 will be A naught. So our initial concentration is A naught. Now what we get from this is A naught is 100% of radium. If A naught is 100%, what is A of 2000? A of 2000 is A naught of half power 5 by 4, right? If A naught is 100%, how much will be this A naught times half to the power 5 by 4? So that is what we are going to compute. The percentage of the radium in the sample after 2000 years is how much concentration is now divided by the initial concentration times 100 is our present concentration, right? This thing, understand this thing. Yeah.
Sir, sorry to interrupt. Is it possible to do this calculation through the on-screen calculator that is given to us?
Yeah, it is possible.
So, but the power is not simple, it's 5 by 4. So, do we use brackets for that?
Yes, you can do that.
You can
Okay.
actually power it to 1.25.
Power by
5 by 4 is 1.25.
1.25.
Oh, okay.
The 2 half power
1.5
1.25.
power 1.25.
Okay. Got
Yeah,
it.
it is possible.
Sir, please explain step 3, sir, one more time. Why we are dividing A naught again?
Okay. So look it like this. If A naught is 100%, how much will be A naught times half to the power 5 by 4? You have to cross multiply it, right? I will just, I should have taken that. See.
Yes.
If your A naught is 100%, how much is your A naught times half power 5 by 4?
Correct.
Cross multiply. Do you know this thing?
Mm-hmm. Yes, sir.
So if I say this is some x, so my x will be A naught half to the power 5 by 4 times 100 divided by A naught. So this is what, this is the percentage of the radium. So A naught is 100% of the radium. How much will be this A naught times half to the power 5 by 4? In terms of percentages, we are computing. That's it. Okay. So this x is the percentage.
Sir, I have doubt in that slide. Can you show that slide again? You have cross multiplied this, right? How do you do this? Right? I mean to say that this is not a linear relationship.
This is a linear relationship, right? A naught, if A naught is decreasing, this is the concentrations, right? These are concentrations, right? This is concentration of radium, right?
Okay, sir.
So if your A naught is full, that will be 100. If this is decreasing, if your concentration is decreasing, the same way percentage of that concentration will also decrease, right?
Okay. Between concentration and percentage of concentration, this is a linear relationship, right?
Yeah. So between concentration
got it.
and the percentage of concentration, there will be a linear.
Yes, I agree, sir. I agree. Thank you, sir.
So that is why we cross multiply. If it is inversely proportional, we will direct multiply. So these are some multiplications or for finding x, where you see in some distance, time distance kind of problems. So where there is a linear, you have to cross multiply this thing. Okay.
So answer is 42.04, isn't it?
42.04 something, but
yeah,
if you approximate it, you will get something like 42. 42 is required to us. Okay. So if you compute this, A naught and A naught will get cancelled, and
even I do not do like this, right? I put 100 in place of A naught.
Even that is fine. That is fine. Even that is good. Just put 100 in place of A naught, and you will directly get what is A of 2000.
Yes, sir. Okay.
Okay. Yeah. Okay. Shall we move?
But sir, in case suppose initial concentration is not given 100%, like say 80 or 90, so the way you did that will give us the right answer, right? Or still it will give the right answer?
Still
it will give the right answer.
Still it will give the right answer. But this is a standard approach we follow. So this
okay.
So now now a question arises: why that answer is correct? Can you explain a little bit, please?
Which
If you
answer
put
is
directly a naught is equal to 100, it gives right answer, but why it gives right answer?
why it gives right answer?
Yes.
Because it is the formula provided.
See, A naught is equal to 100%, right? This concentration is nothing, this A naught is nothing but the 100% concentration, right?
Yes, sir. I did like this.
So if you substitute that 100% in place of A naught, or see, substituting 100% in place of A naught means you are assuming that your initial concentration is 1.
Yes, sir. Got
Okay.
it. Yes, sir.
After that, you will get something in fractions. So if my initial concentration is 1, if you get some 0.42,
yes, sir.
Then you say
then we
that
can convert it into percentage again.
Again, you will multiply it with 100.
Yes, sir.
Okay. Then you will get the percentage of it. So it's
Like it's like converting relative frequency into percentage, right? 0.4.
Right. The same.
Here, anyhow, A naught is going to get cancelled, right? It does not matter whether.
It does not matter. Yeah, that is what.
Yes, exactly.
So that is why we asked you the percentage. This percentage is actually independent of what initial concentration is actually. Okay, it may be 1 or it may be 10 or it may be 200. So depending upon the initial concentration, so what fraction of concentration is left after some years? So that is what we ask you. So when you say fraction, in that particular fraction, this particular A naught will get cancelled. Okay. So this is one standard approach. So people who don't know anything follow this approach. If you can use other ways also, it's fine. So ultimately you should reach 42, no matter what. Okay. Okay, then let's discuss a small thing before we go to the next question. So domain of a composite function. What is composite function? Anyone?
Function of a function. Function of a function.
Input of one output of one function is input to other function.
Right. So function over function. So composition of function is denoted like this: F circle G, where this particular F circle G, first we perform function G, and later after performing that we will perform another function F. So what you are seeing on the screen is about how this composite function works. So once we have a composite function, even that composite function is also a function. So if it is a function, it will have domain, it will have a range. So every function will have a domain, codomain and range. So likewise, even this composite function is also a function. Therefore, even this composite function will also have a domain. But what is the domain of this composite function? So will it be same as after we computing all the things of F circle G, after you compute everything, after finally you will get an equation. So if you compute the domain of that is sufficient, or we need to do extra work or extra thing?
It will, for the second function, the composite function, the domain would be the range of gx.
No, that depends, right? See, that is why we need to understand very clearly what is this domain of a composite function and how to compute that domain of this composite function. So how do we do it is, so actually this domain is nothing but we are taking all the values of x. So we are going to take each and every value of x such that first and foremost thing is that particular x should be in the domain of G. Why? Because that particular x will go into this particular machine or function G first. So on the screen you are seeing, right, this particular black x will actually go into this function G. So if this x has to go into this function and perform my output, this particular x should be in my domain of G. So first and foremost thing is, whatever the x I am taking, that particular x should be in my domain of G. And after this, if those x come inside of this G, they will come out as G of x. So my outputs will be now G of x. Now if you see this G of x, this particular G of x should go into this f. When will this go into this particular function f? When will this G of x go into the function f? Or what values this function f can take? Anyone?
For which the function f is defined.
Right.
No,
So whatever
the
G of
values given, the range given by function G.
Yeah, the range.
not
Intersection
all,
of both.
right, not all the range will go into f. So here there will be another second filter. We say second filter, or you can say anything. First filter is whatever the x is all on all real numbers, only the x which are in my domain G can come inside of this function G, and they will come out as an G of x. And this particular G of x, not every G of x will go into f. Only the G of x's which are inside the domain of f will go into the function f, and remaining will not go, will stop there itself. And what so now what x's we need is, actually x should be in the domain of G, as well as my G of x should be in the domain of f. So if my G of x is in domain of f, then that particular x which satisfies these two conditions, so all set of all such x's is the domain of this composite function. So you can see this particular red G of x, this G of x, if it has to go into this function, it should be the domain, it should be in the domain of this function f, and it will come as an output as f of G of x. So finally you can see from here, this particular x should be in the domain of G, because this x is going into this function G, and this particular G of x is inside this function f. That means this particular G of x should be in the domain of this function f. Only those black x's, all set of all those x's will give me, if I combine that as a set, will give me the domain of this composite function f circle G.
Sir, can I state what I understood, so that means my doubt are cleared? If I am wrong, just please let me know. Okay. First of all, here we are having f of G of x. Okay, so first we start from the inner part. Okay, so we go from x to G, which is x should be all those values which are in the domain of G. Okay, right. Once we get that G, there should be some values will be spitted out, that will be range of G of x will be there, right? And these G of x should be in the domain of f of x. If they are in the domain of f of x, then it will return some value which will be f of G of x.
Right.
But here the condition terminates, or here something different happens. Means if f of G of x should be in any other domain, or it is over here.
It is completed here. This is the output, final output of this. This whole thing is f of G of x. Okay.
Okay.
So x comes in, and our output is f of G of x. So this is the total combined function f circle G.
Okay. Means
this is, if I drew a bigger circle, that will be composite function f circle G. So x comes in, f of G of x goes out. So inside that composite function, what is happening is this is what happening. So that particular x goes into G, comes as G of x, and that particular G of x goes into f and comes out as f of G of x.
But domain matters here.
Domain matters. Yeah, that is why.
Suppose there is a function. Suppose there is a function for which means G of x is not defined for f domain of f. Then it will not get inside that.
It will not get inside. There, the function value, this will break down, and no such function is possible.
Okay. Understood.
Yeah. So that is why follow the stepwise procedure. Firstly, take all the x which are in the domain of G, and then compute the range of this G of x, and compute the domain of this f. So just look at the domain and range of G of x and domain of f. if this range is inside this domain, then every g of x will go into this function f.
Okay.
Right? If this particular g of x, whatever we are getting, if this is subset of this domain of f, then what we say is whatever g of x comes, that will be in my domain f. So whatever
Yes.
g of x comes, that will go into this function. That means whatever x is in the domain of g, that is sufficient to get the domain of this composite function f circle g.
Okay.
So the domain of
Understood.
g is the same as the domain of composite function.
Okay.
But this will be varied if my range of g of x, some values of g of x will not fall in the
In the domain
of
of f.
So that particular g of x's we should neglect.
We should remove it na, from
We
the
should
entire
remove the
set.
x for which x my g of x is not going into the function f. We are going to remove it from the starting x.
Okay.
Okay. So it's like out of this domain of g, we are subtracting something. So that something we will get to know whether depending upon the range of g of x and domain of f.
Okay, got it, sir. Continue.
Yeah.
Excuse me.
Yeah.
So why are we bothered about this domain and the range of f g of x? I mean, I want to know the practical importance of this.
Why are we worried?
Yes. I do agree that okay, it has got any function has got a domain and a range, but why are we bothered?
See, in that case,
can I try and say?
Yeah, I can. Can I try?
Yeah, please.
It is a kind of a double filter kind. For example, if you say that if the student goes to school, then we can tell him a literate one. So if he goes to the school, suppose the G is the school, whether he has gone to the school or not. But f of x says that if he is in class 9th, then only he can play cricket. So X, the student who is the domain in G, this school, he's going to the school, but it might be possible he can play the cricket or he cannot play the cricket. If he is in class 9 or above, then he will be in the domain of fx and then he can play the cricket, else he will not be a part of the function f. Have you got my point? So it is kind that you filtered the you got only after
I can give a more simple example, sir.
Yeah, go ahead.
It is like a sieve, right? A sieve having mesh with big columns and a sieve with a mesh having columns lesser than that. Suppose we have to filter crystals in that. तो सबसे पहले सर जो मोटे क्रिस्टल होंगे कुछ ऊपर रह जाएंगे और उसके नीचे जो आएंगे वो अगेन दूसरी सीव में से
Sorry, I don't understand Hindi. Sorry, I don't get your Hindi.
It is like a double sieve. Okay.
Yeah, he is saying sieve. Basically, something that is used to filter.
Together, consecutive sieves, is it?
Yeah,
Two consecutive sieves. That's what you mean? Okay. Okay, I get it.
Okay.
I understand that the composite function is a consecutive sieve, but I just want to know how do we relate it with the course? That's my question.
You can see it in computational thinking, right? Like three prizes problem. One procedure is to calculate something, then it will go into another procedure. The same result.
Yes.
I think it will be clear when we see an example, I think.
Okay.
Now I understood. You want a practical example or applications of this?
Because we talk about domain and range of this f of g of x. So I want to know why, I mean, f of g of x is fine. Okay, so two functions composited together. But why are we bothered about this domain and range of this f of x? So that's my question.
Because every function is defined over a specified range and the f of g will be defined only for that specific domain. So that is why we are bothered.
Okay.
See, now you will know. See, there is a function h of x which is x. Okay.
Okay.
So you know this function, right? This is a straight line pretty easy.
Okay, fine.
Right?
Fine.
So when you compute, even if I say f of x is 1 by x and g of x is 1 by x, if you compute f of g of x, what will be f of g of x? This is f of x of x. And this is f of 1 by x. And this is 1 by x, which is x. So what is the difference between this particular function And this particular function?
Not much. I mean, it is the same.
It is the same. Huh?
Yes.
See, that is where this composition functions comes to play. So how you are defining functions is matters. Okay. That is what domain gives you. See, I am defining g of x, one function, as 1 by x, right?
Okay.
So if my g of x is 1 by x, what is the domain of domain? It means as a, if I say function, that is like a machine. Okay.
Okay, fine. So this cannot take 0. Okay, I agree.
So
with
if
that.
I am inputting something into the machine, that should give me some output. That should work. My machine should work. Okay.
Okay, it should
For
crash.
what values of this x will my g of x machine work? That is the real numbers minus 0.
Number other than
Minus 0.
Minus
Okay,
0,
fine.
right? Now
Fine.
I cannot take 0. So my machine g fails if I take 0. Okay.
Okay. Okay.
So now if you see
But
here,
on the other hand, h of x can take 0. So that's
h
the
of x
difference.
can take 0.
Fine.
Right?
Sir, this
Okay.
is similar to the roller coaster problem that we have seen in the mock test. It is something somewhat like that. If roller coaster touches some value and like all those things.
Maybe you can interpret it in your own imaginary world, but I don't know. Okay.
Yeah,
So, but,
I can add something. We had a live session on the day after the exam, so the student can watch it if it is required. It was discussed in somewhat detail.
Okay, sure. I'll do it.
Okay, yeah.
Thank you.
Okay.
Thank
Can
you.
you please share the link in the chat so that we can visit once?
No, you can just search it on YouTube. You will find it. It's not that difficult.
Okay.
Okay, fine. So this is about see, when we are studying functions, it is very important to study what is the domain of that function, because domain gives you for all for what values of x is your function is well defined. And range is also a good thing to notice, one parameter to notice, because what is your machine giving, what is your function giving you? So when you substitute something into your function, what all values is your function giving you? So if your function is giving you something in between 0 to 1, and you are expecting something value beyond 1 or less than 0, that will not happen. Okay. So even the range is a good thing to look at, because range gives you what all outputs is your function giving you, and domain is also a good thing to see, because what values you can actually put into your function. So when we are talking about composite functions, so there are two functions involved, which is different from in only one function. So when two functions are involved, two functions will have different domains, and two functions will have different ranges. And when I am compositing it, it will again turn out to be a function, and now again it becomes a function. So then I can take a look at domain, what is domain and what is range, because now this is a bigger machine. So out of this bigger machine, what values I can put in my machine, and what values I can expect out from the machine. So these are standard and important things to be seen when we discuss about functions. So this domain, range,
Got
and
it, sir. Got it.
codomain.
Okay, got it.
Yeah.
Yeah, got it.
Okay.
Okay,
Then
I
we
just
will
wanted
do
to
one
relate
problem.
with the course. That's it.
Yeah.
Okay,
So
thank
let
you.
us do one problem. There are two functions. F of x is something x plus 1 to the power half, and g of x is something x square minus 1, which are well defined. When I say well defined, that means there is a domain for my function f of x, and there is a domain for my g of x, and in those domains my functions are defined. So what I want is find the domain of this composite function g circle f. So this is more than one correct answer. So if you got A, B, C as correct answer, just type A, comma B, comma C. Or 1, 2, 3, 4 is also fine. Okay, just now we have discussed, right, how to go to find the domain. Just follow those steps and you will get it.
Sir, may I ask you question? It's not about this, it's about the qualifier. Just can I ask, can you go to your QPA to qualifier? Can you go to the qualified mock paper? They gave the question paper of qualifier.
Okay, set 1 or set 2?
Set 2.
Set 2, okay. Just give me. Tell me, which question?
The 5th question.
Sir, there is no way to answer, means not A, B, C, D. I have to write A, B, C, D.
A comma B comma C. If you feel A, B, C as correct answer, A comma B comma C. Or 1 comma 2 comma 3. Question number 5.
Question number 5. The elements in Cartesian product will only be in pairs. That's actually correct. So,
will it be correct?
Because Cartesian product is taken between two non-empty sets, so it will always be at least one pair will exist. Like if 1 comma 1 times.
Is A cross B cross C? If there are 3 sets, A cross B cross C. Can't I do that? Can't I product 3 sets?
Yes, sir.
Yes, right?
Yes, sir, we can.
Do it.
It will be pairs, or there are some Cartesian products which are of triplets, quadruples.
Yes, sir, true.
Got it? So every time Cartesian product will not be only in pairs, or every time Cartesian product will not be only between 2 sets. So that is what we wanted you guys to know. So in higher mathematics, you will actually deal with n dimension. So there you will do n sets Cartesian product.
That's right. I didn't see like those types of crosswords, so that's why I got
like in matrix. Like in matrix.
Yeah, matrix, n tuples. We say n tuples. When you get into max 2, you will get to know.
Okay, sir.
Even in week
I
1,
didn't actually, in inter and all, we didn't actually deal with them, so I didn't really know.
Okay. In week 1, sir might have done 3 sets, taking 3 sets, computing 3 Cartesian product of 3 sets, right? So from there, you can see that not always Cartesian product will be in pairs. Okay. So you lost 4 marks.
No, yes.
Okay. Fine.
Excuse me, sir. Sir, when can we expect the results? Qualify?
They are loading actually. You will get by this week, or you will get an announcement before.
4th Feb, I guess.
4th Feb.
Someone mentioned by 9th February.
9th February is a deadline for week 6.
Yeah.
Okay.
According to calendar, it's 4th Feb.
Okay. So those who are talking, are you done with this question?
Yes, sir.
Done?
Yes, sir.
Okay. Let us wait for a couple more minutes.
Hello.
Yeah, hello.
Hi. This Cartesian product will only be pairs. That pair means A comma B, or A comma B comma C will also be called as pair.
No. A comma B comma C is called a triplet.
That is not pair.
No. Pairs are only 2.
Okay. Thank you.
Sir, if the result is on 4th, is there time for the correction to go through, sir?
Correction, what you mentioned? Huh?
Yes, sir.
Yeah, definitely.
Okay.
See, after this session, I will have a discussion with the team, and maybe by tomorrow morning that will be correct. Okay.
Yes, sir.
See, if it is valid, that is why I take it forward. If it is invalid, I should have ignored it. Okay.
And sir, what will happen? Those who give an answer as true,
2, you will get maybe you will get the full mark. Okay.
Everybody will get the full mark.
For which question?
Definitely partial mark we will be giving you partial mark. But if
everybody will get some marks, right?
Yeah, definitely will get some marks. You won't lose marks.
Okay.
So which question we are talking?
That number of values of k. We have given you some 2 quadratic equations, right?
Yeah.
So
what's wrong with that question?
So it's like we have given you at most 1 point, right?
So there was infinite answer.
No.
Number of values of quadratic equation, it has 2 answers.
Right? Quadratic equation, you are finding roots, huh?
Yeah, there were
See,
2.
when we said at most means either it intersect at 1 point or it will not intersect. Even you have to consider that not intersecting case also.
Okay, at most, because of at most 0, 1, 2, all will be
Because
correct.
of at most, yeah, because of at most. So your discriminant should be less than or equal to 0, not equal to 0.
Yeah.
So when you compute discriminant less than or equal to 0, then we have seen that there are 9 possible integer values for k.
Sorry, what is the answer for that?
2 is still correct, right?
2 is correct. 2 is also correct. Maybe it is exactly at 1 point, right?
Yeah.
I have given 1, so means is it wrong?
You have given 1, huh?
Hmm.
Okay, maybe you will get partial marks. Like you have, why did you give 1?
I took exactly case actually, means is equal to 0.
Exactly case you will get 2, right?
The value of k was restricted, right, to positive natural numbers.
Sir, which question means? I think I am talking about different question.
No. Which set you are talking? Tell me that.
I think set 1.
Set 1, we asked you. I am talking about there are 2 functions f of x and g of x minus x square plus 4x minus k. That question.
Okay, that I have given 2 only.
So how to solve that question?
How to
solve that question?
I just explained, right? You will get the solution, don't worry. So with your result, you will get the complete detailed solution.
Sir, is there any correction in set 2 also?
Definitely, right? When
No,
we are talking
set
about
2, it was just 4 mentioned for in the options. The
natural
rest
numbers,
options were
then
10 and 5.
0, 1, 2, 3, 4. So that will be 5. 5 will also be counted as a number. Okay, done this thing. Let's come back and let's look at this thing. Okay, I got 66 responses. Out of those 66, I can see BC very rarely. C, I can see most of you guys have given C. I can see A also.
Sir, these questions will be available somewhere? This question that we are solving now? Because I haven't gone through the material yet, so I'm not actually able to follow.
This slides you will get after this session. This will be uploaded on the portal.
Okay, sir.
Sir, the PDF is uploaded for this?
No. Even you will get I will make this as a student-based activity, and you can actually come into this joinpd.com by typing this code, and you can actually go on.
Okay, solve on our own.
On your own.
Sir, for the revision session that happened on 27th February, can we get the PDF of it?
PDF of it. I will ask.
Sir, I think we are getting somewhere late because back to back there are 2 sessions, sir.
Okay.
Sir, one question out of curiosity. Now, see, there are 4 subjects, and I expect my marks would range between 60 to 70. So, is it necessary? If I don't want to choose statistics, is it necessary I attempt the graded questions of statistics as well?
No, if you
Not necessary, no?
you can choose it in next term, and you can do it in the next term.
But now not necessary, no?
Not necessary.
If you have decided that you're not going to take statistics in this term, then I think you can skip.
Right.
Okay, thanks.
Okay, let us see the solution. So what we have to do first is we have to find the set of all x such that x is in the domain of the function f. Look at here, we are asking you to find the composite function of G circle f. It's not f circle G. Now my x goes into f first, then next in Z. So my first and foremost step is I have to find all x such that x is in the domain of f. So f is given as f is given as x plus 1 to the power half. So for f of x to be well defined, so that is square root of x plus 1. Square root of something, when I have given you functions like this, square root inside something. So in order to be a well defined function, that under root, so whatever the function you have inside the root should be greater than or equal to 0, right? So for square root functions, so inside part should be greater than or equal to 0.
That is
for f of x
for it to have real values, right?
For it to have real values. So yeah, well defined means we are talking about real values only.
Okay.
So function is, if the output is a real number, then the function is well defined for that particular x. So if
So
x
we
plus
can't
1,
have negative values.
no,
That's why we are means we are taking it up to -1 only.
Yeah, complex numbers we consider it as an undefined thing.
Okay.
So when x plus 1 is less than 0, I will get root over something negative which is a complex number. So that is not that is undefined. So if that is undefined, those x values will not be in my domain x. Domain f of x. Okay. So
Yeah,
only
so it
values
is,
of
so it is important to understand what exactly well defined here means.
Yeah,
it
well
basically
defined.
means the real.
Yeah, real. So throughout the course, well defined means a real output. My output is real.
Okay.
So if my x plus 1 is greater than or equal to 0, so for those set of values of x, my function is a well defined, which implies
Sir,
x should be no.
Sir, output is real means you are trying to say that means output cannot be a 0.
Output can also real is
Output
0.
can be 0.
0 is a real number.
It cannot be a negative square root. Negative square root is
It is not
complex.
complex, or it is not infinite, or it is not plus infinite or minus infinite. These are all undefined things. Plus infinite, minus infinite, complex numbers. So we consider these all as undefined things. So 1 by x. So when x is 0, I will get infinite. Right?
Yeah.
1 by 0 is infinite. So that means x is when I substitute x is equals to 0, my function is giving me which is my function is giving an output which is not defined. So for that particular x, my function is not. I will remove that particular x from my domain. Okay. Now you see, when x plus 1 is greater than or equal to 0, that implies me that x should be greater than or equal to -1. Right. So the real numbers, so the domain will be the real numbers, set of all real numbers which are greater than or equal to -1. So whatever the value you take, you substitute in your function, you will get an well defined output. That means a real output you will get. So you take 0 or you take 5 or you take 10, you take 100, whatever. If you take any number, any real number which is greater than -1 till infinite, if you substitute that, you will get a positive, you will get a real output. Okay, therefore the domain will be -1 to infinite. Now we have computed the domain of f of x. Next we have to compute the range of f of x as well as the domain of g of x. Right. Similarly, if you see your f of x, so I will show you in the Desmos itself. So I have given you, so square root of x plus 1. You can see here my graph is lying between -1 to infinite, and also the range of this graph is it's only above x-axis. Right, there is no graph below x-axis, so it's only above x-axis, and y values takes from 0 to infinite.
So why is that? Because there can be negative square root as well, right? If like x is 3 plus 1 is 4, under root of 4 is like +2 and -2. So why are we discounting -2?
No. See, just go back and read the definition of square root. Square root of any real number is positive.
So square root of 4 will be only 2?
Right. You can see here, right?
Okay.
Square root, okay, square root of
Because we often treat when we have 4 and we are doing a square root,
if you take -4 as the -2 as the value, then it's not a function.
Complex number.
no, not complex number, but function. Yeah, understand that square root only if you take the positive part, then only it is function. If you take like 2 values, then it is not a function.
No, see, square root, see, root over 4, root 4 is only 2, not plus or minus 2. Okay, square root is defined like that.
No, as a function, you're saying, right? As if we are taking a square root as a function, then we are calling it, while calling it function, we are restricting it to positive values only.
No, not only function. See, we define things, right? Square root.
Yeah.
So addition, what is addition? 2 plus 4. So I am adding thing, right?
Yeah.
In the same way, square root is also some sort of what we say.
So is it not the opposite of squaring something, right? So
no, it's not. X square is equals to 4
is
different from x is equals to root 4. Okay, x square is equals to 4 has two solutions, which is plus or minus 2.
No, squaring, if
So,
the
but then
operation,
when we take, I have an example here. When we take the square root of b square minus 4ac, we take it as plus and minus value.
No. See, we will write plus or minus root
In
over
the
as an
yes,
operation, sir.
because
As
it
an
will give us plus
operation,
and minus.
Yes, in that example, b square minus 4ac is always positive. Before that, there is a plus or minus.
See, this is x square is equals to 4. How I solve this is x is equals to plus or minus root 4. Okay, this root 4 is 2, and this will give me x is equals to, if x is plus, it will give me plus 2. If it is minus, it will give me minus 2.
So as an operation, right? Squaring is an operation.
Yeah, square root is an operation.
So squaring is an operation, right? So if I square 2, I get 4. If I square minus 2, I get 4 again, right?
4 again.
So square root as an operation, are you saying that we should only consider the positive values?
Yeah, you should only consider the positive. Square root is defined like that. Square root of any real number is a positive. Sorry, any positive real number is positive. This is how we define this operation square root.
Number, sir, negative real number is complex.
It is complex. We don't talk about that things in this course.
This comes as a surprise to me, because most
no, just go into the Wikipedia and search about square roots.
Okay.
Square root will always be positive. So this before square root, which comes plus or minus, that will change whether it is plus or minus. So now x square plus is equals to 4 is a quadratic equation, right? But x is equals to root 4 is a linear line like this. Okay. It is x is equals to root 4 is a line which is parallel to y-axis, and it will intersect x-axis only at this plus 2.
Okay.
So just take a look at this simple definition of square root. So this is how we define a square root. So it's not like something else, or just because of function it is changing. It's a standard definition we define.
My understanding was basically square root is opposite of what we do in square. So 2 and minus 2 and squaring we get 4. So square root basically gives you back both 2 and minus 2. And
no. So have you looked this also? Under root of x square will be mod x. It will not be x.
Under root of x square.
X square. So that is what we are going to see now.
Okay.
So see, under root of x square can be any, x square is a positive number, right?
Yeah.
Root over x square.
Yeah.
But when I'm cancelling 2 and that square root, I am making sure that the inside term is positive, which is mod x. The output will be mod x. So it's an interesting thing. Just go back and search it in the Google. What is square root?
I need to do some reading.
Yeah.
No, if you can define the square root function in set notation, it will be very clear.
Can you give me that? Okay, we will complete this first and we will talk about this. Okay, once we get the domain of f of x, we will also compute the range of f of x as well as the domain of g of x. So the range of f of x, you can see it will start from 0 to infinite. Just now we have seen in the Desmos graph. So y will take values from 0 to infinite. That will be the range of f of x. And if you see, my g of x is something x square minus 1. So this is simple quadratic function, and the domain of that quadratic function is real numbers.
Sir, how can, sir, without Desmos graph, how do we, suppose Desmos is not available to us, then how do we find the range of f of x?
Oh, if Desmos is not available, you know the graphs of square roots, right? Square root of the square root x, y is equals to root x graph.
Yes, sir.
It's an inverse of x square. If you know inverse functions, do you know inverse function?
Yes, sir. I know that.
Inverse functions, you know, right? Okay.
Right.
So if you know inverse functions, this particular function f of x is equals to root x is the inverse function of g of x is equals to x square. Okay. From there you will get. So just draw the graph. Try to compute the graph. So square roots are always be like this. Like this. Square root functions will always be like this. X will be like this. And you can give me anything. Square root x minus 2 will be like this. So square root function will always be like
got
it. Okay. So from there you will compute the range.
Sir, this thing that we just discussed about it is always positive. Is it because we are treating it as a function or operation? Even in case of operation, it would be like positive only, or is it because that we are treating it as function?
Even in operation also it is positive.
Okay.
Okay. So this is square root function, and square root function, that is what I said. Square root will always take positive values. So the range will be 0 to infinite. Okay. It will not give you negative outputs. It will only give you positive outputs. So what are the positive real numbers? 0 to infinite. So that will be the range of f of x. And the domain of g of x is, you can see, x square minus 1, which is real numbers. Now you see, now you observe the range of this f of x is actually a subset of this domain of g of x. So whatever the outputs I get from f of x are all defined in this particular function g of x. So once this is happening, what we know is, if range of f of x is subset of this domain g of x, then we use those two conditions which we have used earlier, which we have talked about earlier. Even if you use those conditions, what we will get is the domain of G circle F will be the domain of F only. Got it? So the thing is, when I take the domain values, when I take the x which are defined, which are in the domain of F, so that will go into this function F, and I will get f of x as my outputs, and whatever the f of x comes as an output, those are our subsets of my domain of G. So every f of x will go into the function G. So as every f of x is going into function G, we no need to worry about how G is working. We just need to worry about this particular first function f. So I will take only x which are defined in this particular function f, and all those will be in the domain of G circle f. So g of f, function G is not making any disturbance to us. So G is defined on all real numbers. So whatever the output I get from f of x, that will go into the function G. So no need to worry about G, only worry about f and compute the domain of f, and that will be the domain of G circle f.
So G is not filtering.
G is not filtering anything, because as domain of G of x is all reals, right? So G of x is taking any real number, whatever the real number is coming as an input, G of x is taking it. And if you see from the functions, when I say f of x are all well defined outputs. So well-defined, when I say well-defined outputs, those are all real numbers. So G is not filtering anything here. So the only filter happening is at F. So therefore the domain of F is same as domain of G of F. So we have domain of F as -1 to infinite. So that is one option. So -1 to infinite, I gave you one option. But now I can, now again, after finding this, as it is an MSQ, what you have to do finally is find all the options that represents this particular interval -1 to infinite. So compute or simplify every other options also and see whether that is equal to -1 to infinite or not. One option which I have given you -3 comma infinite, set -3 comma 5 intersected with -5 comma 1. This particular thing can be simplified to -1 to infinite like this. Just see that. So
means this last option, can you display, means can you do it in a Venn diagram, please, if possible?
Venn diagram or on real line?
Yeah, on real line also you can do.
On real line. I will do it on real line.
Anyway, just.
Okay. So treat it as this is the real line. Okay, I have given you some. Okay, this is 0. This is -3. And I have given you many things. -5. -5, 5, -1. So -1 and 5. Okay. So my interval I have given you is -3 to infinite.
Yes.
-5 to
intersection. Sir, -3 it's given, no?
-3 comma infinite, set -5 to -3 to 5.
Sir, it's -3 comma 5 intersection -5 comma -1.
Right. Now see, first I will identify on number line what this interval is. Okay. So let me take this color. And if you see -3 to infinite.
Yes, that line.
This particular line. Right? From this particular line, I have to subtract something from this. Something from this particular interval. Right? This set minus denotes that, right? So out of this whole interval, I am subtracting some interval. So compute, simplify this interval first. This is -3 comma 5. So what is -3 comma 5?
-3 to all the 5 values. Yeah.
Right.
Sir, these are open interval, right? So we will exclude them.
Yeah. These are open intervals.
Intersection.
And what is -5 to 1?
Okay, from -5 to -1.
Now it is intersection.
Yes.
So intersection is both blue and green region. Blue green line. So this purple thing. Okay. So this particular thing is nothing but equal to -3 comma -1 open. Right?
Okay.
So
and
I
now
have
we
to
will
remove this particular minus purple interval from this whole red interval.
Yes.
If I remove, what I will get? I will get
-1 comma. Okay, got it, sir.
As it is an open interval, here -1 will be included.
Excluded, and infinity will be also excluded since we don't know infinity.
See here, I am not subtracting -1. This is open interval.
Yeah.
Okay. So I am subtracting till -1. So therefore, -1 will be included here. I am not going to subtract -1.
Okay.
So that is why -1 to infinite comes.
Okay. Thank you.
Hello, sir. Sir, are you subtracting -3?
I am not restricting -3.
Sir?
Sir?
Excuse me, sir. Sir, but we have an open interval of -3 to infinity.
Sir, so when we are subtracting this given interval of -3 to 5 and intersecting -5 to 1, we will get open interval of -1 to infinity.
No. See, I am subtracting interval -3 to -1 open intervals. I'm not going to subtract -1. Okay, I'm going to subtract from here to before -1. Before -1, I'm going to remove. So now what will be my interval? So I'm not going to remove -1. I'm just removing till before -1. If it is closed, instead of open, if it is closed,
So
I can't hear you. Okay, so tell me what will happen to this minus. Okay.
So we will get.
Sir, I'm getting confused with the -3 interval. The you have there is an open interval, so -3 will be excluded, right?
-3 will. Okay, even here open interval only, right? Why are you
Yes.
worrying about my? Okay, if it is closed, then you have to worry. Here also it is open. Here also it is open. So from -3, you will eliminate all the numbers till -1, excluding -1. You are not going to remove -1 because -1 is not in this interval.
Hello, sir. I have a question.
Okay.
Sir, if we have to find f of gx, then domain of f of gx, then we have to find the domain of first fx and gx.
If it is like this, you have to find first thing you have to find is domain of G. Next thing you have to find is domain of F and range of G.
So, sir, we don't have to solve this f of gx.
See, if you solve for f of gx, you will not get the proper domain.
Okay, sir.
Okay, that is what will happen. That is what might have happened here to you.
Yes, sir. I
You will
solved
get the range, right? You will not get the domain.
Excuse me, sir. Sir, may I ask a question? Sir, in the given step 4 interval, when we are subtracting the given interval, do we are including -1 in the resultant domain?
Because we are not going to subtract -1 from the original domain, original interval. So
this is because -1 is not involved in this intersection. -1 is not present, no?
Not there, right? We are only have to remove -3 to -1. So this interval only we have to remove from this.
And excuse me, my closed interval -1 to infinity is valid for g of fx. Am I right, sir?
Right.
Thank you, sir.
Well, sir. So, can you explain that the question I asked?
Yeah. What did you ask me? Solving thing, right?
Yes, sir. I solved g of x. Then I got
See,
x.
that is the difference. I already told you.
So, sir, I have to first find the domain of fx and gx. Then I have to conclude the answer.
Yeah, then only you can conclude the answer. So, see here, this is composite function.
Okay, sir.
First, it should go into some function g, and also later it should go into the function f.
Okay, sir.
So whatever x you are taking, that should be well defined in your function g as well as your function f.
Okay, sir.
Okay. You have
Thank
to
you,
come
sir.
by step. If you solve it, you might have got some x mod x.
Yes, sir. I got the x.
So for x, you might have thought it as it is all.
Yes, sir. Then I thought that the all real number will be domain of.
That is where that is not the case here. So composite domain of composite functions to be found in stepwise.
Okay, sir. Okay, sir. I got it, sir.
Sir,
I have understood till range of f of x is equal to 0 to infinity. Right, sir? Then afterwards, how do we calculate the domain? That what values from 0 to infinity would be the domain of g of x?
No, g of x domain is all real numbers, right? If I see g of x is a function, quadratic function.
Yes, sir.
As it takes all real values, 0 to infinity is one subset of that real values. So there is no filtering actually. So whatever the value comes from f of x, comes from the function f, will go into the function g no matter what. No filtering, nothing.
Okay, now
right?
Okay.
Sir,
Yes.
I didn't get step 3. Could you please repeat that?
Step 3.
Yes, sir.
See.
So how come the domain of g of x, g of f of x is equal to the domain of f?
So you understood this particular graph I gave?
Yes, sir.
Right. So now you see, consider your function f takes all the real values. So whatever you give, it will take it. Okay. Set of all real values is your domain of this function f, second function.
Yes, sir.
Okay. Your first function will only take values from -1 to infinite. So that is the defined domain. So your
Yes,
g
sir.
has domain -1 to infinite, but your f has domain whole real values. Okay. Now from here I can only choose from -1 to infinite. This x can take only from -1 to infinite because the domain of g is -1 to infinite, right?
Yeah.
Now after it goes into this function g, later it comes out as an output g of x, right?
Yes, sir.
Is this particular g of x is a real number? As it is coming out from a function, we know that every function gives me a real value, real output.
Yes, sir. It's a real.
Right. Now this g of x is real and the domain of f is real. So whatever this g of x comes will go into this function f.
Yes, sir.
That means whatever x comes into this g will come out as g of x and will go into f and will come out as f of g of x.
Yes, sir.
So here f is not playing any role. So whatever comes out as g of x, it will come out as f of g of x, no matter what this g of x is.
Yes, sir.
Right. So nothing filtering from this f. So finally what you observe is whatever the domain of this particular g, which is filtering in the first stage. So whatever it filters, right? This particular function g is filtered minus infinite to -1 values. So those are not allowed. Only -1 to infinite are allowed.
Yes, sir.
So
Sir, how many slides are there?
Oh, you have to attend statistics, huh? Later 2 questions are
Yes, sir.
very easy. It's like just substituting things. Okay, I can finish it in 15 minutes.
Sir, in the real life, why we included -1, sir?
Why we included -1, I will get to that. Okay, so whatever I said is this particular function f will not play a role because the domain of this particular function is r, any real value.
Yes, sir.
So whatever the domain of this particular g is equal to this whole composite
So
function.
in this case, g is f and f is g, right?
In this case, g just replace f here, g here.
Okay.
Everything is same, just the variable difference. That's it.
Okay. Okay.
Okay. So the first function has domain -1 to infinite. Right?
Yes.
So this particular function has -1 to infinite has domain. So the x can take only values from -1 to infinite. So taking those values, that will go into the function f of x, and the output will be 0 to infinite. Right? This particular range is 0 to infinite, and this particular 0 to infinite can go into g of x. No filtering is happening. All this 0 to infinite is well defined in this function g of x.
Yes, sir.
Right? So that means
Then,
whatever the values x is taking to get the range as 0 to infinite is the domain of this composite function. See, you take ultimately what happens is you will get the domain of your composite function as -1 to infinite.
Yes, sir.
Whatever the value you take in this interval, it will go into f of x perfectly, and it will come some output in between 0 to infinite, and it will go into this function g of x without any disturbances, and it will give me one output.
Yes, sir.
right? So if it is giving like that, that is where it is well defined, right?
Yes,
So
sir.
it is going into F, it is going into G, it is giving me an output. So that is a well defined output. So
Yeah.
whatever x I take in between this -1 to infinite, I am getting a well defined output. So the domain is nothing but for what values of x I will get an well defined output. Those all set of values will be my domain.
So is it are we taking the common area of the domains of fx and gx?
No, no, that is not. Even I thought so, but not.
Okay.
So the range of f of x does not play a role in determining the domain of g of x here then.
Range of f of x, yeah, range of f of x is not playing any role in determining the domain of g of x.
Yes, if that were the case, -1 would not have been included. So clearly, as per this definition, the range does not play a role. Am I right?
Right.
Okay.
So whatever f of x is giving as an output, it will definitely go into g of x because the domain of g of x is all real numbers. So no need to worry about the output of the range of f of x. So f of x gives me a real value output, I know that. So whatever the real value output g of x takes in, so I no need to worry about that function g of x, I just need to worry about this particular function f. So for what values of x will this function f of x is defined? The whole composite function will also be defined for that values of x. So that is what this
I can't you
statement.
think of it like the common area between the domain of fx and gx?
See, that is common area. I will come with an example. Let's just finish this slides, okay?
Okay, sir.
Could you just show the question and tell us about which options are correct?
B and C.
B and C. Okay, thank you.
Okay, so this is fourth question we have. So in a survey, the population growth in an area can be predicted according to this equation. So this is same equation, same question which we have done in question number 2. So there is alpha t. This is the population growth is equal to alpha naught times 1 plus d by 100 to the power t, where d is the percentage growth of the population per year. T is the time taken since the initial population count alpha naught was taken. So if in 2015 the population of Adyar was 30,000 and the population growth rate is 4% per year, then what will be the approximate population of the Adyar in 2020? So t is equals to 0 corresponds to year 2015. T is equals to 1 means 2016. T is equals to 2 means 2017, likewise. So what is D here?
4.
4. Okay. What is T here?
30,000. Oh, sorry. 5 years.
T is 5. Huh?
Yeah, 5.
Okay. What is alpha naught here?
30,000.
30,000.
30,000, sir.
Right. So you have the value of alpha naught. You have the value of D. You have the value of T. So substitute, just find the value. So these are just few questions which involve some calculation parts. No need of thinking anything. Just you have to identify what is what. So what is D, what is T, and what is alpha naught. Just substitute. 0. And again, I need the approximate population. No need to be accurate.
So T is 6, right?
See, T is equal to 0 if it is 2015, 2016 1, 2017 2, 2018 3, 2019 4. What is 2020? 5. So look here, t is equals to 0. We started from 0.
Excuse me, sir. Sir, if we are getting a decimal value, we can just write the next highest integer value, no?
Next highest or below one. Nearest integer is fine. We will consider it.
Okay, sir.
Okay. So in this particular type of questions, it is good to give next integer. Okay. If you are getting something like 49.7, so give it as 50. Even if 49.3, you can give it as a 50. So as we are talking about population growth, so population is an integer always. So if you are getting 49.3,
there's a decimal value of 0.58.
0.58. You can give it to 1. So depends upon the error, right? If the value is very nearer to 0.58 or very smaller values,
Nearest integer will always be right?
Next integer will always be
no. Nearest and next are different, right? Nearest will be always be right.
Nearest will always be right.
Unless specifically mentioned, next you should always be giving nearest.
Right.
Yes.
Excuse me, actually I have a general doubt. Can I ask?
Yeah.
Actually, the quiz one solutions were uploaded in the dashboard, but it contains only one slide which is repeating again and again, and it shows that green tick means correct answer and red cross means wrong answer. It is repeating again and again. There is no
Quiz
solution
one
available.
solutions we have not released yet.
Sir, answer transcript was uploaded. So.
Answer. Whatever you answered, you got it.
But it is not showing any question. Only 2 lines are written, and that slide is only repeating again and again.
Okay. Is it for everyone or anyone can see their score?
No, it is not like that. Maybe you should try to download it again, maybe.
Yeah. Just try refresh, hard refresh. On the link once more. Okay. So done.
Sir, completed.
Done. You guys said right what is alpha naught, what is d, and what is t. Just substitute those in that equation and just find that alpha of phi. Okay. So let us see. Yeah. Many of you have given 36500, 36499. Yeah, 36500 and 36499. Both are correct. Yeah, fine. So the same thing. So identifying the variables is the task. So D is 4%. Alpha naught is 30,000. T is 5. So T is 5 because 2020 corresponds to T is equals to 5. So what we know is the same thing. So identify what is alpha naught, what is D, and what is T. So once you identified it, it's just the matter of substitution. So just substitute it. You will get 30,000 into 1 plus 4 by 100 whole to the power 5.
Sir, I have a question. Suppose in the equation t is not given, so we have to use how we can extract t, means find t.
That is comes with the logarithms.
Okay.
Once you learn logarithms, you will take log of both sides. Then you will get t. Okay. So as of now, this is we are worrying
But
about.
do we have to remember graphs of some common functions like
Yeah,
square root
yeah,
function,
it's good to remember.
exponential
It's
function?
good to have ideas of some graphs of common functions. As of now, you have seen till polynomials. You are okay, I guess. So how the graph behaves and everything.
Yes.
Even exponential functions also good graphs to remember. So they are only increasing or decreasing. It will be only increasing or only decreasing. No more
So can you
curves.
write on a slide, please, that which all functions should we take care of? Like we should know the graphs of those common functions.
Yeah, see, pretty common functions like quadratic, polynomial, square root, exponential functions. Later you will see logarithmic functions. These are pretty much you should understand how e power x behaves and ln x behaves, root x behavior, 1 by x behavior, and x square behavior, x cube behavior, and of course straight line behavior x. So these are pretty common things you should. Even if I wake you in the night 1 a.m. or 2 a.m., you should able to draw. When I give you a paper and a pen to you, you should be able to draw the graph.
Sir, can you repeat the graphs? I didn't got them all.
See the standard graphs: x 1 by x, root x, x square, x cube, and maybe you can see x power n actually. X power n when n is odd and when n is even. And later there are functions e power x and ln x. These are
Sir, I am having hard time understanding the end behavior of x to the power, and means it is very different from the quadratic, polynomial end behavior.
Why it is different? It is same, right?
Basically, if something as root x means, suppose we say x minus 2 to the power half, then
Okay,
it goes to the positive domain instead of negative. That's why means.
I will come to you. Just wait. Let us solve this final question also. So there is function f of x given to you x square, which is restricted in the domain 0 to infinite. Why I restricted? Just because to make it as a 1-to-1 function. Okay. So nothing else is there. So in order to make my function x square as 1-to-1 function, I restricted the domain from 0 to infinite. So once I restricted and made my function 1-to-1 function, then I will have an inverse to it. So what I want is choose the points where the graphs of these functions f of x and f inverse of x intersect each other. So you have to find f inverse of x, which is inverse function of f. And after finding these two functions, I want the intersection of these two. So where this graphs actually intersect, and I want the points of. I want the intersection points. Now tell me, Purendra. So solve this. Once you are done, if you are much confident that it is correct, you can leave. Yes, Purendra.
Yes, sir. Means basically that suppose we are having a value x minus 2 to the power half. Okay. Then our graph shifts to the right and not to the left. While in polynomial, it was different.
X to the power?
X minus 2, suppose we say x minus 2 or x minus 1 or x minus n to the power half. Then it shifts to the right. F plus n, it shifts to the left of the 0.
Right.
Negative and positive values. Sometimes I find it means why it happens like that.
See, why it will happen is when you are saying to the power half, right? It is actually a square root function, right? Square root function always takes inside. So the domain will be the inside part, whatever the inside part is there, that should be greater than 0. So under square root, inside term should be positive.
Okay.
Right. So when you take x minus n, so when will x minus n be greater than or equal to 0?
X minus n x minus n will be greater than 0 when n should be positive.
No, not when x is greater than n. So
yeah,
okay, when x minus 4 is there, when will x minus 4 be greater than 0?
If x will be greater than 4.
X will be greater than 4. So my function will only be defined when x is greater than 4. That means when you see on xy plane, your x values will take from 4, not from 0. So it will start from 4 and it will go to infinite. So when the function is
That's why
minus,
we are not starting from 0.
yeah. So when it is minus, you will move to the right hand side. When it is plus,
Yes.
what happens is x plus 4, if it is there, x plus 4, root over x plus 4. Okay. Now inside part should be greater than 0. So just follow the domain, how you compute the domain. So inside part should be greater than 0. So x plus 4 should be greater than 0. When will my x plus 4 be greater than 0?
When x itself will be greater than 0, 4.
Minus 4.
Minus
X
4,
plus, x plus 4 is greater than 0. Just take that plus 4 to the right hand
to
side.
that side, it will be minus 4.
Yeah. When x is greater than minus 4, it is sufficient for me to conclude that my inside part will be greater than 0.
Okay, means I was thinking like square root of 0. So I take 4 minus 4. Suppose x minus 4 you said. So x said before, then 4 minus 4 is 0. Then why are we not starting from 0?
No.
So it should be always be greater than 0.
Greater than or equal to 0. Even square root of 0 is okay. Okay. That is how you compute. So that is what you have to remember also. So when it is like x minus of some real number, you will start from right side of it, right side of the y-axis. So if it is x minus 5, you will start from 5 to infinite. If it is x plus 5, you will start from minus 5 to infinite. So in sign change, there will be a sign change. Okay.
Yeah.
If it is minus, it will be plus here. If it is plus, it will
Sorry
be
for interruption, sir. Hassan here.
Hi.
So I have a question regarding previous question you have just
I will go to that.
Sir, the question is, what if instead of 4% per year, there is 4% per quarter in a year?
It will be like,
then how will transform the equation given here?
It's just like d by 4 into 100 to the power 4 into t.
Okay, means quarterly means 4 times, na?
4 times. Here denominator you will get 4, and here in the power you will get 4t.
Okay, sir. Thank you.
Okay. So I got 50 responses. Everyone done?
Yes, sir.
Okay. So let's see. ABC. I can see ABC also, ABD also. Okay, 110000 AB. Yeah, good. So most of you have given AB. So how do we proceed is first and foremost thing is like we have to find what is f inverse of x. So find the inverse function f inverse of x. How do we find this? You know how to compute inverse functions. So I need to get a function g of x such that f of g of x should be equal to g of f of x should be equal to x, right? So I consider a function g of x which is square root of x or x to the power half. Now what I will do is I will compute f circle g. So f of g of x, f circle g is nothing but f of g of x. So f of x to the power half. So f of x is x square, f of x to the power half is x to the power half to the square. Right? Once you compute f circle g, I will get this. Now you see, if I have to cancel these things, I will get mod x. So I can write mod x as x because I have restricted the domain to 0 to infinite. In 0 to infinite, mod x is.
So how will you get mod?
I just explained, right? Root over root x to the square. So when I'm cancelling that root and square, my inside part should be positive.
Okay.
Okay.
Okay, sir.
Okay. The same thing goes here. So this is root over x square. So whatever that should be positive. Okay, this is g circle f and that is f circle g. Okay, anyway, here what it happens is we are squaring it. So I don't think here we require mod x. This will be directly equal to x. So there is a correction here. So this will be directly equal to x because we are square rooting that x and later we are taking the square of it. So square of that any real number will always be positive. So no need to be specifically mention mod x. So it will be equal to x. But whereas G circle F, we are actually computing square of one number and root over it. So when I say root over it, definitely that is positive value. Therefore we get mod x. So this particular mod x will be equal to x because we are considering only the domain from 0 to infinite. In 0 to infinite, mod x will be equal to x. So now I got f circle G as x and G circle F is also x. So I can say f and G are inverses to each other. Therefore I can say G is the inverse function of f. Therefore f inverse of x is root x power half, which is root x. Now I got f inverse of x and also I have f of x, which is x square. In order to find the intersection points, I just have to equate f and f inverse of x. So if I equate it, I will get x square is equals to x power half. If I simplify that, I will get x power 4 minus x is equals to 0. Further simplification, factorizing, you will get x into x minus 1 into x square plus x plus 1 is equals to 0. If you see here, x square plus x plus 1 has no real root. So if you compute the discriminant of this, you will get less than or equal to 0, less than 0. So therefore I can say x is equals to 0 and x is equals to 1 are the only roots for this. So at x is equals to 0 and x is equals to 1, actually this function f and this function my f inverse will intersect. So find the intersection point.
So
So the
could you
points
please?
are.
Oh, sorry. I think you can finish first, then I'll ask.
Okay. So the points are at 0 comma f of 0, which is at x is equals to 0, and 1 comma f of 1, which is at x is equals to 1. So f of 0 and f of 1 is 0 and 1. So therefore I can say that the intersection points are 0 comma 0 and 1 comma 1. If I have to show it in the graphical way also, if you see here, f of x, the red graph is x square, and f inverse of x, which is root x, is this blue one. So inverse functions are always mirror images to y is equals to x, symmetric about y is equals to x. So once you know x square, I can always draw root x. So it's just the symmetric with respect to y is equals to x. So if you see here, even the graph cuts at 2 points, 0 comma 0 and 1 comma 1. Okay.
Sir, is it a must that inverse functions must be mirror images in y is equal to x always?
Yeah, they are mirror images with respect to y is equals to x.
Okay.
They
And
will.
one more. Okay. And there's one more thing I wanted to ask. We said that g of f of x was the inverse of g of x in the domain 0 to infinity. What if we didn't have the restricted domain? Would there be inverses then?
No, there will not be inverse. See, x square is, if I take on whole real line, x square will not be a one-to-one function.
Yes.
So inverse exists only for one-to-one function.
Yes, because this one will fail the horizontal line test.
Yeah, if it is whole R, it should be like an U.
Yes.
So if it is U, then horizontal line test will fail. So
And so it can't have an inverse. It's not invertible.
It's not invertible. So that is why I said, right, I restricted the domain to make this function one-to-one. So that I will have an inverse.
I have in activity question, sir.
Yeah, I will take
Sir, just one question. Sir, just one question from this slide only. Sir, can I please?
Yeah, whoever done, you can leave and join statistics session. Thanks for joining.
Sir,
yeah.
Sir, can you open question number 3, sir?
In this slide?
Yes, sir, in this slide.
Okay.
Sir, I have 2 dots in this. First of all, sir, can you please explain again what is this term defined, well defined? And second, sir, why not domain of f is minus infinity to plus infinity?
Okay. Okay. So yeah, those who are done, you can leave. So those who have doubts, just stay with me. I can take 15 minutes more and
Same problem, sir. Can you please explain the composite function? Is that rule 1 and rule 2 as explained in videos?
As the?
So as explained in videos, sir, rule 1 and rule 2.
I just showed it in the slide, right? See, first thing is, okay, I will tell you. One is f of x given to us as this, and g of x is given as x square minus 1, right? So when I say well defined means this particular f of x function has some domain and has some range, and out of those domain values, if I substitute it, I will get the range values. So that is what well defined means. Okay, it has some domain, and in that particular domain it is well defined. Okay, if I have to find the domain of this particular function f of x, this is under root x plus 1, right?
Okay.
Now see, our domain is set of all x such that f of x, when I compute f of x, this particular f of x should belong to real value. Okay.
Correct.
So those x values will belong to domain. If f of x is a real value, so for that particular x will lie in this domain. Okay. Now what I want is this particular f of x should be a real value, right?
It should be positive real numbers, right?
Which one?
The f of x.
Yeah, it should be positive because it is in root.
I am talking about
cannot
definition of
technically.
domain, not for
Oh,
this.
okay.
I'm just talking about what is the domain of a function. So domain of a function is set of all x such that my f of x is a real value or well defined. Both are same. F of x is well defined is same as saying f of x taking real values. Okay. Now in this case, if my f of x has to take real values, my inside part, so whatever is inside square root should be positive. So then only I will get f of x a real number, right? Under root of some number is positive if this under root is greater than 0, is undefined. Okay, I will take this as some y. So square root of y is positive or a real number if my y is greater than or equal to 0, or undefined if my y is less than 0. Okay, this is what square root function is. This is how we define square root function in our course. Why we are saying this undefined? Because it is going into the complex values. It is taking complex values. Okay, if my y is less than 0, it will take complex values. Now instead of y, we have x plus 1. Okay, I will just substitute x plus 1 in place of y. So if I substitute x plus 1 here, it will give me a real number if x plus 1 is greater than or equal to 0. It is undefined if x plus 1 is less than 0. Okay, x plus 1 is greater than or equal to 0. It implies nothing but I will just take this plus 1 to the right hand side. I will get x is greater than or equal to minus 1. Okay, this is same as this. And this is same as x is less than minus 1. So for x less than minus 1, this particular f of x is undefined. For x greater than or equals to minus 1, it is giving me a real number. That means my f of x is a real number. So I have to find the domain of this function f of x, right?
Yes, sir.
So what is the domain now? If you can see here. So for x being greater than or equals to minus 1, I am going to get the real values for f of x. So that means only for values which are greater than minus 1 will say me that this function is a well defined. So that means this domain will be equal to x greater than or equals to minus 1. If I wanted to denote it in the intervals, show it on the intervals, I can write it as minus 1 to infinity. Right? This x greater than or equals to minus 1 is nothing but all the values which are right to minus 1. So this particular interval is nothing but minus 1 to infinity. Okay, domain of this function f of x is minus 1 to infinity. That is how you get minus 1 to infinity. Yeah, there are some doubts for activity. I have noted. Is it there
So
or
for
he
the
left?
same question, I had
Okay,
a
I will.
doubt.
This same domain question, huh?
Yes, sir.
Okay.
Sir, it wasn't clear to me why we weren't taking the common between the domain of fx and gx.
Okay. I will give. You asked this, right? Domain of f of x and domain of g of x is sufficient. Why we are considering other things?
No, sir. I thought that the domain of the composite function is the common area between domain of fx and domain of gx. Is that
So
correct?
no. You are saying that if this is domain of f, if this is domain of g, so this will be the domain of composite function. So
Yes,
that is
sir.
what you are saying. No, that is not true. Because I will tell you why.
Okay, sir.
So see, I will start with giving some x into this some function f, right? So
Yes, sir.
firstly, to find the domain of f, just now we have seen how we find the domain of f, domain of any function. What we do is we input all the values of x and we see where this function is actually giving me the output. So that is how we get the domain of this function f, right?
Yes, sir.
So this x, if you treat it as whatever the x comes into this function f will be in the domain,
Okay.
right? Domain of f is this particular x where f of x is defined or belonging to real values.
Yes, sir.
Okay. Now what happens is this gives me f of x. Okay, this is one function. In composite function, other thing is f of x will go into another function g and my output will be g of f of x. Okay, if you are confusing, I will take f of x as y. Okay.
Okay.
Now instead of x, my y will go into g and my output will be g of y.
Yes,
Okay.
sir.
So the same thing I will apply here also. So now y goes into g only if g is well defined, right?
Yes, sir.
Not every y goes into this. Okay.
Yes,
This
sir.
particular y is different from this particular x. Here y is f of x, not x.
Yeah.
Okay. So if some values are not going into this g, let's say some y1 is not going into this g. So if I substitute y1, which is in this f of x, but it is not going into g because there g is not defined.
Yes,
Okay.
sir.
So for that particular y1, there will be an inverse image, right? F inverse of y1, right? For this output, there will be an input, right?
Yes, sir.
That input, I will remove it from the domain of f. Okay, I will not remove y1. I will remove f inverse of y1.
Okay.
So means from the beginning x only.
Beginning x. From this x, I will subtract the pre-image of this y1. So as y1 is not going into g, y1 is an output of f. As
Yes, sir.
y1 is an output, for this y1 output, there will be an input, right? There will be an input
Yes,
which
sir.
is f inverse of y1. I will remove this f inverse of y1, not y1. So okay, I will give you an
Okay,
example.
sir.
Sir, where did you get y1 from?
Okay, I will tell you here. So I will take very easy examples. I will take f of x as 1 by x. Okay.
Yes, sir.
And I will take g of x as root x. Root x I don't.
Okay.
Okay, root x is also fine. Okay.
Yes, sir.
Now I have to compute f circle g. Okay, f circle domain of f circle g of x.
Yeah.
Now what set of values of x will go into this g of x? So this is g. What is the domain of g?
Positive real number.
So 0 to infinite, right? 0
Yeah.
to infinite can go into this g. And what is the output?
Also 0 to infinity.
0 to infinity. Right? So now you see this particular 0 to infinite will have to pass through this function f, right? When I take 1, 2, 3, 4, any value other than 0, it will go inside this f, right?
Yeah.
Okay. So there is 0, 1, 2, 3. This is the domain of f, right? Domain of G, this particular G. So every value will have an output, right? If it is x1 here, there will be root over x1. Output is root over x1. If it is 2 here, this will map to root 2, right? This, you say this is a function G. This is function f now. So whatever comes here, this will map to 1 by root 2, right? This is, our function is 1 by x here. This is root 2. Now my output will be 1 by root 2. Likewise, for root x1, there will be 1 by root x1. So these are just mappings. Function is a mapping. So this particular 0 will map to 0 here. And this particular 1 will map to root 1, which is 1 again. Like this particular 3, because this is root x. And this is a function and it is a mapping. So 3 will map to root 3. 4, whatever input I take, root over that will be my output. So whatever output I get, that will go into this function f. And function f is defined as 1 by x. So this root 2 will be, when I input root 2, I will get output as 1 by root 2. When I input root x1, so this is x1, root x1 and 1 by root x1. But if you see here, 0 is an output of this particular function G, right? When I input 0, I will get output 0. But if I input 0 into this function f, will it take or not?
Undefined.
Undefined, right?
Undefined, sir. Yes, sir.
What I will do is, I will remove this 0.
Okay.
I will remove this 0. If I am removing this 0, whatever the pre-image of this 0, okay, if I remove this, automatically this will also be should be removed, because if I take this, I will get this, and this will not go to f. This should not go into f. So if I have to remove
Okay,
this,
sir.
I have to remove this one also. Okay, I will remove
Yes,
this,
sir.
this. Ultimately, what I will be left with is 1 to
Just so
infinity.
this will affect the domain.
Which will affect the domain?
The removing of 0.
Removing of 0.
Means, sir, previously
Usually,
the domain was from 0 to infinity. Now it will be from 1 to infinity.
now it will be from open interval 0 to infinity. I just take
Yes, yes, sir.
0.1 something.
Yes, sir.
Real numbers will also be there.
Oh.
Okay, sir. Okay, sir. Thank you, sir.
Okay.
Thank you, sir.
Even this one, if 0 is mapping to some root 7, just say, just say this root 7.
Sir.
If 0 is mapping to root 7 and root 7 cannot take, if root 7 is not in the domain of f, you have to remove this root 7 as well as this 0 again. Okay. People
sir.
usually tend to remove this root 7. As in your case, if you say intersection part, you are saying that this will be removed, and you will say the domain will be something from 0 to infinite, removing root 7.
Oh.
That is not the case. You shouldn't remove this root 7. You should remove the pre-image of that root 7.
Okay, sir.
You have to play with this thing only. You can
Got it,
finally,
sir.
I will end this with this thing. Always your composite function f circle Z domain will always be a subset of domain of Z. Okay, just think about this. In the next session, maybe you will get, we will try to give you a clear idea.
Yes, sir.
So whatever the domain.
Thank you so much,
Sir, I
sir.
have a small,
Thanks a
sir,
lot.
I have a excuse doubt. Me, sir. Only a small doubt. Like, if we have the domain to be R, like all the real numbers, then the multi-select questions they have given R and R minus 1 or 1 to infinity or minus 1 to minus infinity. All the answers would be right.
If the domain is R, if it is given
But
like
the
this,
multi-select question is
no. So usually in this particular course, what we ask you is set of all x's. So domain is basically all x. So if you choose this thing, you are saying that minus 2 is not in my domain. Okay. So if you are choosing this option as correct, I agree, even in this interval also the function is defined. But when you are choosing, when you are saying it as a domain, that means that -2 or whichever is less than -1 is not in your domain. That is what you are saying if you are choosing this option. It shouldn't be that case. Okay.
Sir, I have a question regarding inverse functions.
So is it not
Sir,
becoming late to you? There is a session, right?
No, sir. I am not attending that.
Okay. Why so? You wanted to leave statistics, is it?
No,
I
no,
can see
no, no.
33 people. You can actually. I'm done. The agenda of this
Okay,
session
sir.
is
So
done, and
shall I
you can
proceed
leave.
with the question? Okay, okay.
Yeah. I'm talking about other guys. So those who
Okay.
wanted to attend statistics, you may leave and you can attend that. Yeah, you can ask.
Okay, sir. So regarding inverse functions, let's consider all functions that has an inverse function. So how to systematically proceed to find the inverse function, sir? Because in the last question you started, I mean, you already knew that for x squared, root x is
Okay.
the inverse function.
Okay. I will tell this. So see, we know that if you know f of x, if you have f of x, I will assume that I don't know what is g. I say that g is the inverse. But what I know is if g is the inverse, I know this thing, right? F circle g of x should be x, as well as this g circle f should be x, right?
Okay.
Now I will take first thing. So this will give me f of g of x should be x, right?
Okay.
So you know f of x. Let's just say it is like 5x plus 4 by 2x minus 3 kind of thing.
Okay.
If your f of x is 5x plus 4 by 2x minus 3, what will be your f of g of x? So substitute this g of x in place of x, right?
Okay.
This will be 5 times g of x plus 4 by 2 times g of x minus 3 should be equal to 0.
Okay.
Now just solve for g of x in terms of x.
Okay.
So 5 times g of x plus 4 will be equal to 2x g of x minus 3x.
Minus 3x. Okay.
Right? I will bring g of x on one side. 5 times g of x minus 2 times x into g of x is equals to minus 4 minus 3x.
Okay.
Right? I will take g of x common. You will get 5 minus 2x is equals to minus 4 minus 3x. So you will get g of x as minus 4 minus 3x divided by 5 minus 2x.
Okay.
Okay. Once you get this, just check for the second condition also. Okay. Is it happening or not? So now you have g of x with you. You have f of x with you. Just compute f of g of x. If it gives you x, it will give you x. Now just verify. If it gives you x, then this particular g of x is the inverse function of this function. 5x plus 4 by 2x minus 3. It's simply like you are just substituting g of x inside f of x function and trying to find g of x in terms of x. That's it. You can use this method.
Okay.
Okay. Yeah.
So for question number 5, I had a different approach. It was the inverse question, right?
Yeah.
So I took I plotted the graph for y equals to x square and x equals to y square for the inverse. Is that correct?
Yeah, x is equals to y square. Okay, that is
And the
nothing but
y
y
equals to
equals
x
to root x,
square.
right?
And then I just found the common point.
Yeah. See, x is equals to y square is same as y is equals to root x. So
Oh
just
yeah. Sir, for inverse, can we replace x with y and for the inverse function?
yeah. That is also a good method.
Okay, sir.
If
Thank
you
you.
have this is y here, f of x, take it as a y. Just find x in terms of y.
Okay, sir.
Then replace back. Okay. Just
Okay, sir.
One last question, sir, please. Sir, could you please explain this vertical line test and sir horizontal line test? Means when we should use the horizontal line test in what type of case?
See, this horizontal line test and vertical line test you can use when you know the graphs of function only. Okay, when actually you can plot the graph, then only you can use this horizontal line tests. So these are just testing. Okay, so when you know something functions like this, graph of function like this, if you know the graph, then this particular line tests are performed. If you don't know the graph, then this is not the good approach to find whether it is 1 1 or on whether it is 1 1 or whether it is a function or not. So when you know the graph, you can actually perform it. And how do we perform is, you see, you just have to start from either side. If you are performing vertical lines, I start drawing vertical lines on the graph. Okay.
Okay.
Everywhere. So either you start from the right hand side or left hand side. So I will draw straight vertical lines. When this vertical line test fails is, if I have at least one line like this, if I draw one vertical line like this, such that if this vertical line intersects my graph at more than 1 point, like let's say 2 points or 3 points, intersecting any line out of these all lines, even if you get any one particular line such that it intersects the graph at more than 1 point, then your vertical line test will fail. If you cannot come up with one particular vertical line, then you say that vertical line test is passed. So whatever the line I draw, it only intersects only once on the curve.
Yes, sir.
Then I say vertical line test is passed on that curve, and I say that particular curve can represent a function. So if vertical line test is passed, it is a function.
Okay.
Okay. Same with horizontal line test. Here what we perform is we draw horizontal lines. Okay. You can start from above or from below. Okay, I will use different color. So I can draw like this. So you can draw any line. Even x is equals to 0, y is equals to 0 is also a line, horizontal line. So if you see here, this particular line, I am drawing this particular line, right? When I am drawing this particular line,
Just
it actually intersects
more than 1
curve
point.
at more than 1 point.
1 point. Correct, sir. Yes.
So if it is intersecting more than 1 point, even if you get one particular horizontal line such that it is intersecting more than 1 points on the curve, then you say horizontal line test is failed. Therefore, it implies that the given function is not a one-to-one function. First, you perform vertical line test. You conclude whether it is a function or not.
Then you
perform
horizontal.
horizontal line test. Then only will perform horizontal line test. How horizontal line tests are performed to check whether it is one-to-one functions or not. Vertical line tests are performed whether to check it is a function or not. Firstly. Okay.
Okay, sir. Thank you, sir. Thank you so much.
Okay, thanks. Yeah, thanks a lot then.
Thank you, sir. Thank you.
Thank you, sir.
Yeah, I'll meet you in the next week.
Thank you, sir.
Yeah, thanks. Yeah, Rahul Aditya, I will look into that qualifier question. Okay, if you are here or if you left, it's okay, fine. Okay, fine. Thanks for joining and have a good day.
Thank you, sir.
Excuse me, sir. Excuse me.
Yeah.
Sir, I have been disconnected. I have asked that question, right? For example, the ranges are and the sub options are all correct. So we need to select in this course only the R, or do I need to select all the rest of the options?
No. If it is subset, you have to choose the whole domain, not the subsets of domain.
Okay, sir. Yeah. Thank you, sir.
You have to choose.
Thank you.
Okay. Host, you can end the session.
Hello?
Yeah, hello.
Sir, I have a personal question. Actually, I couldn't write quiz 1 due to COVID, sir.
Okay.
So now what will happen to the quiz 1 marks, sir?
You haven't written, right?
Yes, sir, due to COVID. So will they conduct again for COVID, or how can I get other marks?
No. You have to give one more qualifier is going to happen on March 13. You have to give that.
That will be counted as quiz 1 for us, sir.
That will be counted as a qualifier for you, and you will directly come as a term student if you qualify that in the next term.
I have already qualified, sir. I have selected for M1.
Okay, you already qualified, is it?
Yes, sir.
Then you okay. You haven't given quiz 1, right? So
Yes, sir.
there is a calculation. If you just attempt quiz 2,
Okay.
then there is a you will only be accounted for 95% if I am not wrong.
95%.
Yeah,
So,
95% or something. So 0.1 taken from the graded assignments. Point some 6 is taken from end term, and 0.25 is taken from, I guess, I don't know, 0.5, 0.35 or 0.6, and so 60% of end term and 25% of your quiz 2 and 10% of your graded assignment, or 50% of your end term, 35% of your quiz 2
quiz 2.
and 10% of your graded assignment. So totally you are only be able to get 95%, not the
I
whole
can.
100% will be given.
These bonus marks and all, will they send us a sheet or something, sir? Because I have been attending classes, but I don't see attendance record anywhere.
Okay, it is being recorded in our end. Okay.
Will they share with us, sir, so that we can be
We
cautious?
don't share you the bonus marks, I guess. It will only impact your grades. Okay.
Okay.
So if you are expecting you will only get B, if you have some good set of bonus marks of 10 marks, so we will add that bonus marks and we will keep your grade up. We will hire your grade and give you A. So only it affects only for grades.
Only
Nothing
grades.
else. Yeah, only grade is effective. If you are good in if you have some good set of bonus marks, you can expect a good grade. You can expect a better grade. That's it. But it
Okay,
will not
sir.
make you pass the course. Okay.
Pass from quiz 2 and end term I should do, but if I
You
want
should pass
improvement in my
from quiz
grade,
and end term.
okay.
Okay. If you are
Thank you,
doing,
Sir,
okay.
Excuse me,
Okay.
sir.
Yeah.
Sir, one last question. Sir, for this qualifier, do they consider the graded assignment marks and all, or
No,
is it just
nothing.
no only?
No.
Okay.
So
Excuse
graded
me, sir.
assignment is for your hall ticket.
Okay, fine.
Someone
Sir,
want-
actually, I have a doubt. Actually, I'm not well since 3-4 days, and I'm not able to attend the session and also study properly. So, will I have an extension for the graded assignment of this 5th?
See, that is why we have given you 6 out of 9, right? So even if you are okay with submitting 3 or 2 assignments, it's fine. No worries.
Okay, that is one issue, sir. Okay, I have one more issue. Now, after we get the results and if we pass in our qualifiers, will we be counseled for what kind of courses, what is suitable for us?
Yeah, definitely.
That will be there.
Yeah.
So at present, I can also choose and attempt those assignments.
At present, now you are allowed to choose assignments, but once you get the qualifier result, then you may not be able to give, I guess. So if you have got only 40%, you should choose 40 or something 50 to 60, I guess. 50 to 60%, then you are only allowed to choose only 2 subjects, right?
That is two courses.
Yeah, only 2 courses. So you
Yes,
have to choose it quickly, and rest of the 2 courses you will not be able to see. You will not
so
be able
the
to
counseling for that will be given.
Counseling for that, I guess there is a orientation session going to happen, I guess. Last time it happened. I don't know about this term. We will look into that.
Because we need to know which is suitable for us, what kind of,
Yeah.
how do we have to go forward. And also, sir, actually, I have a doubt that if we do not qualify, so how do we how is it the next process? What should we do?
See, you can give the exam again on March, right?
Yes, March 13th.
Yeah, March
And
13th.
then yes, sir, actually on March. So will all the date the assignments, whatever the graded assignments, will it shown in the dashboard? Will we have the access to the dashboard? How will it be?
Yeah, till week 4 you will have the access to the dashboard.
Even if we do not qualify.
Even if you do not qualify, you can have the access till week 4. Again, you can go back and prepare from weeks 1 to 4.
Okay, sir. Okay.
Okay. You can prepare, give it in the March 13, and once you qualify that, you will directly come as a term student in the next term. No need
That's
to give
from May.
4 weeks and everything. Okay. So there
That's
is no
from May.
qualifier again to you.
Yes, sir. But it starts from May this time.
May. There you can choose 2 subjects or 3 subjects depending upon the time you have. You can directly choose 2 subjects or 3 subjects or 1 subject. There is no
Yeah.
mandatory that you should choose all the 4 in that particular term.
No, it's not suitable for me because I have even other work too.
Yeah, that is why. That is why.
Yeah.
Once you qualify, you no need to again give the qualifier of all the 4 subjects. Once you qualify in
So
March,
until March 13, I needn't. I mean, whatever my percentage weekly graded percentage will be the same for the March 13th.
Yeah, for March 13 will be the same, and you will get the hall ticket, and you will give the quiz. You will give the qualifier.
Yeah.
But you will get enough time to prepare. Now this
Yeah,
February,
that's enough. That's enough.
you can again go back to the weeks 1 to 4 and prepare, and you can give the qualifier on March 13.
So
No
can
need to
I
wait for
ask
April.
your personal opinion about these subjects, sir? If you have any idea, should we have to take? Because I'm preferring Maths 1. Along
Okay,
with
if you
that,
prefer Max 1, then go for English or CT. You wanted to take 2 or 3?
I want to take only 2, sir.
Only 2. Then
Per term.
okay, with Max 1, I prefer to. I suggest you to take CT because you have some common in between Max and CT. So there is some graph theory called graph theory.
Oh.
So you will have an interconnection between Max and computational thinking. Some sort of. So you can go in the same pace. Once if you understand one subject, it is very easy to understand you the other.
So they're aligned together.
Aligned together, and you can. It will be like you are studying only one subject, but you are covering the 2. So that is something like coding, simple coding. Now that you have seen weeks 1 to 4, you might guess how the computational thinking will be.
Okay.
Here it will be pure max, and there you will just do it in on screen and coding and everything. So there
Okay,
is
so
an
Maths
interconnection.
and CT are better.
Yeah,
Somebody
Max and
has
CT.
written in one of the WhatsApp, right, saying that it is now this qualifier will act as a quiz one for this session, whatever the term. So I am fine. I'm thinking my CT marks will be little. That is going to make any difference.
CT marks is going to be little low, is it?
Yeah, little low. What I am feeling.
But what we got is like some 90% or 91% pass percent for C. Don't worry. See,
Okay.
pretty decent scores have come out. And be positive.
Oh, when are the results, sir? 4th?
It's on February 4th, they are saying, right?
Yeah, as early as we know, because
even
we can decide what to do.
right.
Even I am on the same boat.
Yeah.
Someone raised the hand.
Yeah.
Yes, sir. Sir, I have general queries. I'm not joined to discussion forum. And how to join, because I'm mail to I support team. I am not received any invite link.
Are you term student or qualifier?
Term student.
You are term student, right? Why will you get discussion forum? You will get discourse, right?
Discourse. But sir, discourse form link not approved, sir. Not send.
Not sent to you.
Yes, sir.
How long it is? Like it's already week 4, week 5. We are going to end. Haven't you said in the initial stages to anyone mail someone?
Yes, sir. I have mailed, but support team says ki I can check my dashboard, but not any invite link was shown.
Dashboard. See, you can check it in the dashboard, no? You want the link only.
No, sir. I can check, but not any link show.
Acha. Okay, let me open my dashboard and let me check whether I am able to go into discourse or. So you are using 22 T1 MA001 site only, right?
Yes, sir.
Okay. So just give me 1 minute, okay? Okay, there is course, scores, announcements, forum.
Yes, sir.
Click on that forum. What are you getting? What do you get? I am directed to discourse directly.
I can say welcome to IITM PDS and login. Then I will log in, but it's a wrong.
It says wrong.
Yes, sir.
Okay, do one thing. Just go to incognito. Incognito. Just go into incognito. Just open with your
Yes,
mail,
sir.
with your official mail.
Okay.
पहले mail open करो. Okay. After opening mail, next tab में open this seek.onlinedegree.iitm.ac.in.
Yes, sir. I can open it.
You can open it.
Yes, sir.
You can see now.
So, ma'am, I mean, I can use Hindi language, sir.
Yeah.
सर मैंने न्यू इनकॉन्ग्रुएंट टैब पे ही यूज करती हूँ सर, बट मैं मोबाइल में यूज करती हूँ.
ओके, मोबाइल में यूज करते टाइम पे क्या होता है पता है? You might have come into you might sometime log in with your personal mail IDs. So when
Okay.
you log in with your personal mail IDs, it will redirect back to saying that you are not subscribed or it will not show you anything. एक बार लैपटॉप में खोल के देखो ना. You don't have laptop.
Okay, sir. Okay, sir.
You have laptop, right?
Yeah, okay, sir. Thank you.
क्या? I asked you question. You have
No,
laptop or
नहीं, आई जस्ट वांटिंग. मैंने लैपटॉप पे भी नहीं ओपन किया. मेरे को लगा मोबाइल पे हो जाएगा मेरा, बट मैं काफी बार ट्राई की, मेरा नहीं हो रहा था. मैंने सोचा
अच्छा, एक
मेरे पास कर सकूं.
बार लैपटॉप खोल के ट्राई करो.
ओके सर.
थिंग इज ये तो 5 तारीख को आ गए हम. सी 5th week को आ गए थे हम, राइट? So
यस
this
सर.
week should be done in the first week or second week. You might have missed many threads. Okay. So be
Okay.
quick. If you are not able to log in, just come in the next session. Just select again. Say that I have also informed previously to the other instructor. He has
Okay,
given
sir.
me this suggestion. It didn't work. I'm just waiting from past 5 weeks.
Yes,
Just do
sir.
me as soon as possible and we will take it forward. Okay.
Okay, sir.
Okay. Okay. Chalo then. Bye. Take care. Bye everyone. I'm just leaving. Okay.
Thank
Everyone
you,
done,
sir.
right?
Thank you for your
Yeah.
Thank you,
patience.
sir.
Thank you. Thanks a
Okay.
lot. Thanks a lot.
Fine. Yeah.